We're in the mechanical room in this house. Can you point out some of the energy efficient aspects of this? You know, what makes this more of an energy efficient house than what a typical house might be?
Sure. One of the first things you probably want to look at is what type of heating system you're using on the house. This happens to be a Coleman modulating furnace. If you look on newer furnaces, they always have an energy label guide down here, and this one says it can be as efficient up to 97.5%. So that means that basically 97.5% of the heat that this furnace generates actually makes it into the house. The other 2.5% will actually go out the exhaust piping and make it to the outside. Older furnaces, if you're looking at an older home, a lot of times you'll see metal chimneys on furnaces, and that means that heat is going to go up the chimney. With technology the way it is right now, this furnace is nice for a number of reasons. One is not just its efficiency, but it also comes with an ECM motor. An ECM motor on a furnace actually is going to cost quite a bit less than, say, an old motor. Furnaces that are older with the metal chimneys and that sort of things typically don't have the ECM motor. They're probably going to run somewhere between 500 and 800 watts every time that fan turns on. This one is probably going to run about 100 watts or less when it's running. So it's a big savings on the electrical side of things, but also on the modulating side, it's going to not use more gas than actually what it needs to heat the house. So if this is a 60,000 BTU input furnace, we might be supplying 30,000 BTUs input just to heat the house. So it's dependent on what the house needs for heating needs. Some of the other aspects of this house, aside from the furnace, is that we do have a gas water heater with a nice smart valve on it. So gas water heaters, this is also kind of it's a power vent, but also we can use a PVC chimney because we're actually using less heat into that chimney. So more of the heat is actually staying with the water heater, same with the way it is with the furnace. And then lastly, in this mechanical room, we'll talk about the HRV. HRV is actually essential, especially in a house like this. It's as tight as it is. This house actually comes with a 0.05 air change per hour. That means 5% of the air is naturally changed in this house every hour. ASHRAE would say that 35% air change per hour is actually healthy. So we're way off from that 5% to that 35%. So the way that we make up for that is we put in an HRV. An HRV actually brings air in from the outside, heats the air up using the heat that's already in the house, and puts it into our furnace system and distributes that fresh air through the building. And one of the nice things about it, and its actual benefit is the fresh air in the house for the occupants, so that we're getting fresh air all the time from the outside. We're not breathing that recycled air that's stale inside the house. And of course, the other feature to this thing, or the advantage of having it, is that it actually is controlled by a controller that will allow us to set the relative humidity in the house. It's blinking 46 because we want it to get down to 46%. It's reading that it's over, at this point, it's over 46% humidity. So there's different controls on here as far as speeds, and anything that goes over 50% is actually a little bit too much for a house. Then we start worrying about mold and things like that. So we like to stay within a healthy humidity level, and this is one of those ways that we can do that.